2 volt input, we calculated gain 4.3. 4.3 multiplied by 2, it is 8.6. As we calculated that our voltage will approximately 10.3 volt, but because this signal is now slightly less than the required level, because its resistor value is slightly less, it is 4.7k instead of 5k. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session we will design non-inverting amplifier using LM324. It is 4-channel operational amplifier IC. Positive, negative, out, non-inverting input, inverting input, IN, NI. LM324 datasheet. Four operational amplifiers, 1, 2, 3, 4. Every operational amplifier is separate from the other. We will use any one segment. There are single channel, 2 channel, 4 channel operational amplifiers. We can select as per our requirement. But I am selecting LM324, positive, pin 11, ground. We can apply maximum 32 volt or plus minus 16 volt power supply. That is maximum limit. So I will use 2 power supplies, plus minus 12 volt. In operational amplifier we inject any signal. Here I will use my self-made simulation signal. We will connect 2 resistors, 1 potentiometer, 10 kilo ohm, 10 kilo ohm, 5 kilo ohm. So we will divide these 24 volts by using this potentiometer. 10 kilo ohm, 10 kilo ohm, 5 kilo ohm. 24 volt multiplied by 5 divided by 25. 5 kilo ohm this one and 25 kilo ohm. Total resistance 4.8 volt. From this point to this point 4.8 volts. Because we are not considering any ground, we are taking 2 power supplies. And if I will check the other 2 resistors, 9.6 volt here, 9.6 volt here, remaining 4.8 volt across this potentiometer. I will connect 5 kilo ohm potentiometer, one resistor here 10 kilo ohms, and this 10 kilo ohm resistor here. Now we have a signal. We have one input signal and we have 12 volt power supply, plus minus 12 volt. And our input signal is 4.8 volts. This 4.8 volt, there will a center point, 10 kilo ohms here, 10 kilo ohms here, 5 kilo ohms here. When we will divide this potentiometer in center, that time this side and this side resistor will equal. 10 plus 2.5, 10 plus 2.5. So 12.5 and 12.5, that time this point will center. When we will take 2 power supplies from here, we will not connect ground to this IC. This is now ground point. We will connect this ground to inverting input. When this IC will receive dead center 0, that time it will provide low output, 0 output. When it will start to increase, the output will start to increase. We have 12 volt positive and 12 volt negative. If the gain is uncontrolled that time, if there is minor difference here, it will cause to increase the output at maximum level. First we need to control the gain. We want to use this operational amplifier in 10 volt range. 12 volt power supply, but to make it fail safe without any distortion, without any saturation, we will use in 10 volt window. Normally we will derate power supply 10%. If 12 volt minus 12 multiplied by 0.1, it will 10.8. I am taking 10 volt range. Input signal 2.4 volt here, 2.4 volt here, and we want to plot this signal into these values. When 0 volt, output 0 volt. When the input signal will reach at 2.4, this side will touch to 10 volt. Output will increase at 10 volt. If the input signal will drop at 2.4 volt minus with respect to this ground, that time the output level will decrease to minus 10. We will consider one side peak, 2.4 volt. We want to convert into 10 volt. So gain V out divided by V in. V out 10 volt divided by 2.4. We need again 4.166. 10 divided by 2.4, it will around 4.167 gain. To adjust the gain, we need feedback network. We need a resistor that is connected as a feedback. This one resistor as an input resistor, this point will be connected to ground, and we need a resistor here that will be connected between these 2 points, RF feedback resistance and R1. When we want to calculate gain for non-inverting amplifier, gain is equal to 1 plus RF divided by R1. Now gain is known. We need 4.167. 4.167. 1 in formula. RF we need. R1 we need high value resistor. Let's suppose 10 kilo ohms. 4.7 minus 1. 1 will be shifted here. 4.166 is our required gain. Minus 1, when we will shift this one, it will become minus here. So it is 3.16. To keep RF in one side, this 10 is now divided here. We will multiply here. 3.167 multiplied by 10, it is 31.6 kilo ohms. Feedback resistor value will 31.66 kilo ohms. So it is very difficult to find this value resistor. We will select a resistor value that is 33 kilo ohms and this resistor 10 kilo ohms. Now we will see how much the gain. We are using 33 kilo ohms. Gain, now we will calculate gain. 1 plus RF 33 divided by 10. The new gain will 4.3. We will multiply 4.3 with this one to check either the signal will saturate or not. 4.3 multiplied by 2.4. The maximum signal in upside will 10.32. So that's safe. Let's connect this circuit. 32.78. 32.78 kilo ohms. When we calculate, the calculation is something else. When we select physical component, that is with tolerance. Now it is 9.87 K. 9.87 K. This 9.92, we calculated 10 kilo ohms. So sometimes there is a slight difference in the result. That result is due to the components 9.82. Its printed value is 5 kilo ohms, but it is 4.7 kilo ohms. If we check its second section, because it is stereo, it is also 4.75. Now let's connect. I will use these two power supplies, 12 volt power supplies. This power supply line terminal will reach to line terminal of this power supply. And we will connect line voltage here. Then this power supply neutral to this neutral, and we will provide second line side here. Now both supplies will turn on together. Positive, negative, positive, negative. This power supply negative terminal to this power supply positive terminal. This supply negative terminal will reach to positive terminal here. Now this end positive, this end is negative. This is negative output. Here is positive terminal. Now we have two power supplies, positive, negative. And this is center point ground. Now first we will turn on these power supplies. Now we will adjust these power supplies. We will connect common lead to the common point. It is minus 11.53. We need to adjust this power supply at 12. Minus 12 volt, positive 12 volt. So we have now balanced power supply. Now I will connect these negative voltage to this IC pin number 11. Pin number 4 is positive. This time I am using dual power supply. Negative voltage at pin number 11. Positive 12 volts at pin number 4. Here is cut mark 1, 2, 3, 4. We can connect single supply or we can connect double supply. Here I will connect 10 kilo ohm resistor. Second 10 kilo ohm resistor at this point. This resistor will reach to one end of this potentiometer, and this resistor to one end of this potentiometer. Now we have two resistors. Now we can use any one section. Number 1, number 2, number 3, number 4. Pin 7 output of second stage, pin 6 inverting input, pin 5 non-inverting input. We will use this segment. We can use any one. Now let's check the result of potentiometer. Common. It is approximately dead zero. Now we are moving in positive side. Clockwise minus 2.33 volt. Counterclockwise plus 2.31 volt. And clockwise minus 2.3 volt. We calculated 2.4 volt, but because its value is 4.7k instead of 5k, so that is reason there are a small difference in the output. No problem, it is within range. We will connect this output to pin number 5. Now this input signal will go to pin number 5, and we have pin number 6 and 7. At pin number 6 we will connect two resistors. One resistor 10 kilo ohm, it will go to this ground potential, to the center node, and this one 33 kilo ohms, it will go to output pin. Two resistors together will be connected at pin number 6. The 33k resistor will go to pin number 7, and this 10k resistor will reach to this ground point. We will take output from pin number 7. Our connections are ready now. Now I will power it on. We are receiving 10.09 volt in minus because Our signal is now in minus. Now I will move it counterclockwise to make it positive. As I am decreasing the signal, the signal is decreasing. With the same ratio, we are receiving output voltage. As we calculated that our voltage will approximately 10.3 volt, but because this signal is now slightly less than the required level, because its resistor value is slightly less, it is 4.7K instead of 5K. .3 volt positive input, 10 volt output. Now I am decreasing the voltage. If we'll multiply this value with the gain, we will receive this voltage. .2 volt input, we calculated gain 4.3. 4.3 multiplied by 2, it is 8.6. Our calculated gain was 4.1, but using 33K resistor the gain was 4.3. And now exactly the same which we calculated. 2 multiplied by 4.3, it is 8.6. I will decrease the voltage now to 1 volt. One volt, 4.3, the same calculated gain which we calculated using this formula. Minus 1, 4.3, minus 4.3. Because it is a complete theory, complete science. So in upcoming sessions, I will discuss each parameter, each step in detail. In this tutorial, we checked how we can calculate gain, how we can plot a signal in the output. This was our 2.4 volt signal. If our signal is in millivolt, that time we need higher gain. When we will need high gain, that time we need high value feedback resistance. 2.3 volt, 10 volt. Minus 2.3 volt, minus 10 volt. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.